P-value. P-value is the tail area measured from the location of the sample. Let's have a look at this framework here. So first of all, the horizontal axis is referred to as the distribution. In other words, it includes all possible values for the underlying variable. Now at the center of this distribution is the null statement. So most of the times this would be what we think is the average of the entire distribution. So the whole issue is whether the sample supports this null statement or whether it rejects it. So with p-values, what we're doing here is we're measuring the resulting tail area from where the sample lies. So we have two samples in our illustration. In the case of sample 1, it falls over here. So therefore the resulting tail area would be this right there. And you can see that as the sample deviates further away from the null, then the resulting p-value or tail area would be even smaller. So the first thing we notice is that the smaller the p-value or the tail area, it would indicate the larger deviation away from the null statement. So let's formalize this discussion. So the further that the sample statistic deviates from the null, the lower the resulting p-value will be. In other words, again, ladies and gentlemen, the trick I have for you is p-value is tail area. So when they say the lower the resulting p-value, it's the lower the resulting tail area. And the more likely it'll be that the null will be rejected. Well, that kind of makes sense, right? So you can argue that sample 1 is fairly close to the null, so therefore we would accept it. But if you look at sample 2, it's really deviated away from the null. So sample 2 is less likely to support the null statement. Now specifically, we reject the null if the p-value is less than the level of significance. And let's do an illustration to see how this plays out. Suppose that in a one-tail test, the level of significance is 5%. So what the level of significance does, ladies and gentlemen, is that it forms the goalpost. So there it is, level of significance. It forms the goalpost for the entire null acceptance range. So that's it. Level of significance tells you where the goalpost is. So the only question is, does the sample fall within the goalpost, in which case that'll be null territory? Or does the sample fall outside of the goalpost, which is outside of null territory, in which case we would reject it? So let's look at our two scenarios here. In the first case, the p-value is 0.07. So that's a pretty bigger tail. It's a bigger tail than the goalpost. So the goalpost only had a 5% tail. So when the p-value is 0.07, it means it stretches further inwards. So that would be an indication that the sample falls within the null range. So we would accept the null. On the other hand, when the p-value is smaller than the goalpost tail, so again, the goalpost is determined by the level of significance. So that's fixed in our illustration. It's fixed at 5%. That's where the goalpost is. So if in the second scenario, the sample yields a p-value of 0.01, that's an even smaller tail than the critical value. And therefore, that would be an indication that the sample came outside of the goalpost, right? So it's right there. So that smaller tail means a larger deviation away from the null. And as a result, the conclusion would be that we would reject the null because the sample fell outside that null acceptance range. So let's formalize our conclusion right here. In case 1, it fell within the null range. See that? It's within the null range. And remember we said this is a goalpost, so everything here is null range. But what can you observe about case 1? The p-value was greater than the level of significance, right? In case 1, it was 0.07. However, in case 2, you can see that the sample fell outside the null range, But then what's the resulting observations in the tail area? Well, if the sample fell outside of the null range, it would mean that its tail is even smaller. In other words, its p-value is less than the tail that's created from the goalpost. And then, of course, the conclusion is that we reject the null. So there's two ways to look at it. You can see if the sample statistic falls within the null range. But so the other angle here is you just compare the p-value with the level of significance. They will both give you the same result because, ladies and gentlemen, we are using the same framework. We are using the exact same framework. Now, tip, the p-value and the level of significance must be compatible. So if you're looking at a one-tail test, p and level of significance represent the area of just one tail. But if you're looking at a two-tail test, then p and level of significance is the sum of the areas of the both tails. So in our illustration, we were kind of looking at a one tail. So we're comparing the level of significance for one tail with the p-value for one tail. But if this was a two-tail test, so if we had, so let's say we had a 90% range for the level of, 90% acceptance range for the null, then the level of significance would be 0.10, because you're looking at this side as well, and the p-value would be 0.14. So you're just doubling because you have two tails.